Assalamualaikum and a very good day to everyone. My name is Fauziatul Nadhirah binti Hilmi and I'm going to present my final year project, which is Synthesis, Characterization and Antibacterial Studies of Acetophenone derivatives and its copper and zinc complex. This project is supervised by Dr. Karima. I will start with research background, where shift base is formed by condensation of carbonyl in primary amine to produce azometine, while shift base complexes is a coordination compound where ligand bind to the metal. Next, the issues proposed is many existing drugs are less effective on some bacteria due to poor solubility, toxicity, and limited spectrum. So, shift-based metal complexes are the potential alternative to this problem. Next is metal ions, which is copper 2 plus and zinc 2 plus that bind to the ligand will affect compound electrical characteristics. The objective for this project is to synthesize shift-based ligand from 2,4-dihydroxyacetophenone with O-phenylenediamine and ethylenediamine with their copper and zinc complexes via reflux. To characterize compound using CHNS elemental analysis, physical analysis, FTIR, UV-based and NMR spectroscopy. And last one is to evaluate antibacterial using this diffusion method. The next part is literature review. The synthesis of shift base is found by Hugo Schiff, and the synthesis steps are mixed reflux for 3 hours, cool and filter, and also dry. For characterization, CHNS elemental analysis is to find the percentage of CHNS elemental in compound, which is carbon, hydrogen, nitrogen, and sulfur. And next is physical analysis is to indicate melting point and the color of the product and also the percentage of the product. The next one is FTIR spectroscopy is used to confirm presence of azometine group. And then the UV base is to identify electronic transition, while NMR is used to identify chemical shift in the compound. The next part is method. For methodology, synthesis shift base using 2:1 molar ratio of acetophenone and then we undergo reflux for 3 hours and characterize. The step is repeated using other diamine, which is ethylenediamine. For metal complex ligands, the steps are the same, right? With 1:1 molar ratio of ligand to metal and use copper to chloride and also zinc to acetate. The next part is result and discussion. For the result, for CHNS elemental analysis, it shows good agreement with theoretical values, which confirming the successful synthesis of both ligand and metal complexes. But a slight deviation may be due to the incomplete drying or excess salt. Importantly, sulfur content was 0% as expected from the structure. And then for the melting points, also support the purity with ligand 1 and ligand 2 having narrow ranges. For copper ligand 1, it shows that higher melting points suggest strong metal to ligand bonding. Meanwhile, for copper ligand 2 and zinc ligand 2 showed lower metal point than ligand 2. It's indicating structural changes due to coordination. For the next part is for FTIR spectroscopy. FTIR analysis further confirmed that coordination. For ligand 1, we observed the azometine and phenolic stretching band. Upon complexation, azometine shift from 1602 to 1611 cm3 1 in copper ligand 1 show coordination via azometine nitrogen, while new band in copper ligand 2 such as metal and oxygen and also metal nitrogen stretches also shows metal coordination. The next part is UV-based spectra. It shows that pi to pi star and n to pi star transition for both ligand in 200 to 300 nanometer range. In copper ligand 1 and copper ligand 2, new broad bands appeared around 350 to 400 due to the DD transitions, typically for copper 2 plus. In contrast, ligand for zinc ligand 2 showed no DD transitions, as zinc 2 plus has no D10 electron configuration. This confirmed the formation of complexes. And then the next part is NMR spectroscopy. It shows that proton NMR spectra of ligand 1 and ligand 2 showed distinct signal for azomatine. For ligand 1, we can see azomatine proton appeared around 7.66 to 7.68 ppm, while for ligand 2 and zinc ligand 2 at 7.51 ppm. The similarity in ligand 2 and zinc ligand 2 spectra showed that ligand remains intact upon complexation, but minor shifts still indicate metal binding. In conclusion, to conclude, acetophenone-based shift-based ligand and their copper-2 and zinc-2 has been synthesized. However, zinc ligand 1 complex was not obtained, likely due to the low reactivity or solubility issues. And then the next one is the structure were characterized using CHNS analysis, physical analysis, FTIR, UV-based and NMR spectroscopy. It shows the presence of azomatine group that confirm the shift-based formation and successful metal ligand coordination. However, antibacterial testing was not conducted due to the time limitation. This will be a valuable direction for future work. The next part is recommendation. For future research, I would recommend to explore other biologically active metal ions such as cobalt 2+ and nickel 2+. The second one is to improve copper ligand 1 by synthesis to increase the yield or purity. And the last one is to adapt green chemistry approaches like solvent-free synthesis to make process more sustainable. That's all from me. Thank you.